everybody. That was just pitiful. Really sad. Good morning, good afternoon, whatever. There we go. A little better. Maybe next year it'll be better still. Oh. All right, are we codes up on the screen? Good stuff. Whew. I don't know about you, but these allergies have really gotten me down. So if you see me like turning blue and wheezing, don't worry. It's probably fine, but whoa, those allergies. All right. Good stuff, everybody. Hi, welcome, welcome, welcome. My name is Josh Long. It is so very good to see you all today. I'm really happy we're all here. Have you had a wonderful DevOps UK or the best DevOps UK? Yeah, there you go. Wonderful. I love DevOps UK. This is such a great show, despite my presence. Wonderful, wonderful show. My name is Josh Long. I work on the Spring team. Spring developer advocate, Kotlin Google developer expert, a Java champion, and most cringe-worthy of all, a YouTuber. Oh, so awkward, so awkward. Look, please join me here. The adventure will be fun. We'll do it. We'll do it together. It'll be fine. That other website, the bird site, is on fire, and I'd like not to be stuck there. Thank you. So join me here. Anybody here use YouTube? YouTube. Yeah, okay, so it's some of you. The rest of you, you'll get there. You'll get there, it's fine. What about email? Emails, anybody here using email? No, good, moving on. My friends, we have never been in a better position, never been in a better time to be a Java and Spring developer. And I talk to people about this all the time because I just cannot believe how lucky, how good, how amazing we have it right now. And I say that fully aware of where we are and where we've been in the ecosystem. How many of you have seen this wonderful website here? spring1.io/history of Spring. Good stuff, like a handful, despite my having shouted it from the mountaintops. This is a wonderful thing that we did last year to celebrate the 20th anniversary of the early access, not GA yet, builds of Spring Framework, and the 10th anniversary of the early access, not yet GA builds of Spring Boot. And this year, of course, we celebrate both the 20th and the 10th anniversary of the GA builds of Spring Framework and Spring Boot, respectively. So an amazing thing. So you can just play this at home. Press the little arrow bar there. Rod Johnson publishes the book Addressing J2E Complexities back in 2002. How many of you know this? Fun fact. Spring had documentation before it had code. Did you know that? We wrote the book, and then the code came from that, not the other way around. It was sort of one of those things where it's just like people gravitated towards the ideas, and it became formalized, and eventually the project as we know it, that looks something like what Spring Framework 1.0 would eventually be, that was in 2003, about a year later. So Rod Johnson, Jürgen Holler, and Jan Karoff start the Spring Framework open source project. Spring Framework 1.0 released in 2004, Spring Security. Now we're going down. We got Spring Data, NoSQL workloads. We got Spring Boot 1.0 in 2014. We've got 2014 Spring Batch 3.0 released with Spring Boot's dynamic capabilities. We've got Spring Integration in 2014. And now we're up in the clouds. I hope that's not too subtle. I hope that's kind of clear what's happening here. So we're in the clouds. Spring Cloud 1.0 released 2015. We've got Spring Cloud Task introduced supporting short-lived microservices. We've got Spring Cloud Stream 1.0 2016. Spring Cloud Dataflow 2016. Now we're going back down where? To the water. Yes, maritime theme, right? Kubernetes. So Spring Cloud Dataflow for Kubernetes 1.0 orchestrates long-running streaming and short-lived task batch data workloads. Spring Cloud Skipper. Here, this takes us to Spring Cloud Gateway for Kubernetes, which automates deployment of an API gateway. And of course, we enter the modern era of Spring in 2022 with Spring Boot 3.x and Spring Framework 6.x, enabling a lot of cool stuff. And we'll talk about, of course, some of that stuff today. And of course, then we get here, celebrating 20 years of innovation in the Spring ecosystem. So when I say there has never, ever been a better time to be a Java and Spring developer, I say that fully aware of our incredible history, both in the Java ecosystem and the Spring ecosystem. And I've been around for most of that time. I remember when Java was synonymous with client-side browser-delivered applets. And so now to see it has come as far and amazingly as it has, well, yeah, it's a privilege. So, my friends, to demonstrate all of this, we're going to do as we always do. We're going to go to my second favorite place on the internet. Who among you knows my first favorite place? Thank you. Some of you know. Some of you spoiled it for the rest of the class. Got to stay late and clean the chalkboard. So we have start.spring.io. We're going to build a brand new application. By the way, they added a new feature. You don't even notice it. They added a new feature to start.spring.io. If I choose Kotlin, refresh the page, it still says Kotlin. Isn't that cool? So, it's awesome. So it has memory now, right? So I've chosen Java. Anything's fine. I'm going to choose Java. It doesn't matter. I'm going to use Maven, and it's Spring Boot 3.2.5. That's the latest and greatest, though. Knowing my luck, they'll probably release 3.26 in just a minute. And we're going to build a new service. And of course, here, friends, we always have a difficult time. We have a lot of consideration that's required here. We need to name the service. So I'm going to call my service Service. And the reason I'm going to do that is because, again, I am great with names. Just amazing with names. Absolutely amazing. I get that from my father. My father was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Amazing with names. We had another dog, and that first dog disappeared after like 10 years. I don't know what happened to him. Maybe he got a job. And then another dog showed up, and my dad named him Two. Amazing, amazing. He was a small white dog, just like the first one. Very, very good with names. That said, my mom tells me all the time, she says, "You're very lucky that I named you." And yeah, that's probably true. So then we have a choice about what version of Java to use. And friends, here, obviously, there's only two real choices here. You see, while you could use Java 21 and 22 reliably and capably and usefully, I would recommend strongly, urge against even, vociferously dissuade you from using Java 17. You see, to do so is to be guilty of software malpractice today. If you have the chance to use Java 21 or later, you should. You should absolutely be using Java 21 or later. It is truly amazing what they have given us in this release. The last time I was here for DevOps UK was yesterday. But before that was the day before. But before that, it was a year ago. And you know what they've done since then? They released Java 21 since then. And that Java 21 is, in my estimation, the most important release of Java ever, right? I think you've got like Java 1.0 and then 21. All the stuff in between, pretty good. I'm a fan. But 21 was huge, and we'll talk about why in a bit, okay? But really, really amazing release. What else? We need to have some dependencies here, friends. I'm going to add the GraalVM native image support. I'll add the web support. I'll add the Postgres support. I'm going to add the Spring Data JDBC support. It's 2024, so I'll add some OpenAI AI support. What else do I need? I want Docker Compose support. I want some DevTools support. Okay, I think I'm pretty happy with my selections there. But you do you. You can choose whatever you like. I love Java 20. I want to go back to this. It's very important. Super important here, right? Obviously, I don't even know why we have this one anymore, right? Remember, it's been 10 years of Spring Boot, and when we started Spring Boot, I went around telling people about my preference for .jar. Big fan of .jar. Not a big fan of .war, right? This is a part of my overarching guiding personal philosophy of make jar, not war. And again, very, very important to be on the same page here, right? So that's good. But Java 21, again, technically superior in every way. More robust, more syntax rich, more operations friendly, more capable. In every single way, it's better. Technically superior in every way. It's also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. So I'm going to open this up in my IDE. While that's loading, can we take a selfie? Okay, good. I didn't hear, I'm just going to, okay, thank you. Gee, okay, everybody pretend like you're happy. Ready, steady, open source. Oh, yeah. Oh, hi. Look at him. All right. That's awesome. Thank you. Oh, I know that sound. You've got a Canon Sony A7S III, and it just lost power. Oh, it's okay, buddy. I do that. Mine does that all the time. Especially when it gets too hot, like the sun comes in, and it turns off, the camera heats up, and it won't continue. Really strange. Thank you for that. What I'm gonna do is I'm gonna take that photo, I'm gonna show that to my daughter, and I'm gonna say, see, they listen to me. Here we go. That's a Chris Richardson joke. I love that joke. I love Chris Richardson, and I love that joke so much. Okay, here we go. Public static void main. First things first, we're going to talk to a database, right? So you saw back on start.spring.io, I created a Docker image. It has, I had Docker Compose support. I'm going to expose this port here, but the Spring initializer was nice enough to create the Docker Compose file for me. And so if I want, the Spring Boot application, when it starts up, will automatically it'll automatically connect to that for me, right? The problem is that it'll start the container for me if it doesn't exist, and then when the program stops, it'll stop it as well, which can be a little disconcerting. The last thing I want to do is wait for Java to start up a Docker image every single time I'm waiting to recycle the Java program. So I'm going to just start it and then and leave it started, okay? Start only. I also have dev tools, so I don't need to really do a full restart anymore either. I'm just going to reload the Spring application context. You see, Java is many wonderful things, but fast out of the door, it is not. And one way you can make that fast is by not restarting Java. Just restart the Spring application context. Eventually, though, we're going to also have a production build of this code. So I'm going to use Spring Data Source JDBC, URL equals JDBC : PostgreSQL localhost my database, and then username, and then it's my user. That's what was specified in the Docker Compose file, okay? So there we go. I think that's good. And then finally, we're going to have some schema, aren't we? We're going to have some schema here that defines the data schema for our application. So we'll say schema.sql. Here we go. Create table if not exists. Customer. Same old customer. Primary key. Okay. Text. Name. Text. Not null. By the way, out of curiosity, who's using Postgres? Who just doesn't care about their data? I'm just a big Postgres fan, honestly. Who's using Oracle, the database, which is awesome? Okay, good stuff. SQL Server? Yeah? Oh, look at that. What about MySQL/Maria? Oh, more than 0. Interesting. Interesting. Okay. Okay, so we've got a table. We want to initialize the data. So I'll create another file here called data.sql. I'm going to say insert. I'm going to say, well, first of all, I'm going to delete the data. So delete, delete from customer. And then I'll say insert into customer, name, values. And I'll just put some people in the Java community that are awesome, okay? So we'll put Alina, hi friend. I'll put myself in there. We'll put, who else is awesome that I've seen today? Oh, Sandra, there we go. We can put Mark. We can put Andres. We can put, who else? Sorry?
You have a typo in the schema.
It should be name.
It's not name in your schema file.
Okay. In the schema, what did I do wrong? Okay, going back. Don't worry, I got this. Name. Thank you. Pair programming for the win. Okay. Watch this. Accent, and I'm American. Woo! Look at that. First try. First try. It only took me 14 years, but it was the first try. What else? I don't know. What is that? We got Dr. Sire, one of my favorite doctors. We've got Dr. Subramaniam. There we go. Subramaniam. Yeah, there you go. So that's, what is that? Is that 8 records? That looks like 8 records. Yeah, it's 9 total, so if I take 1, that's 8. So that's a nice round number. I can divide it by 2, and then 2 again, it's still 2. Makes it easy to sleep at night. Now, friends, I want to build a data-centric application. Obviously, I'm going to use a customer. This is an entity, a record rather, from Java 17 and later. I'm going to use an entity, a record, to describe my entity called a customer. And I'm going to use Spring Data JDBC. I love records. Who is using records? Java records. Good stuff. The rest of you, get on it. This is awesome. I love records. Okay? Huge fan. Huge fan. Big fan. And this is one of the many features that they introduced in Java 21 since we last spoke, that I think if you take these things together, makes for a very amazing situation. In fact, Java language architect Brian Getz talks about data-oriented programming. How many of you have heard about this? Data-oriented programming. Okay, well, it's a really a new paradigm in Java 21. It's a culmination of a lot of different things that were introduced in earlier versions of Java that, taken together, give us the ability to do some really cool things. And the basic conceit, the premise of this is that historically Java has thrived in the world where you have large monolithic applications with deeply seated hierarchies of abstract types. And if you wanted to introduce change into the system, you did so in terms of specializations of these abstract types. You created new implementations of interfaces. You created new subclasses of hierarchies. And that was the dimension by which you introduced new things into a system. But we're no longer building these huge monolithic applications, are we? Instead, we're communicating in terms of network boundaries. Increasingly, we have smaller code bases. Increasingly, the data that we send across the wire from one service to another, usually ad hoc, stringly typed data, in fact, is the vector of change. I change my system by adding support for processing a new kind of message, right? Kafka, REST, RabbitMQ, RSocket, gRPC, whatever. All of these are messages. They're not method invocations, right? So we have to accommodate that. The language has to grow to support these use cases. So there's a number of features here, including records, which we've just seen. There's sealed types, right? There's pattern matching, and there are smart switch expressions, okay? So what do I mean by all this? So let's take an example, okay? Let's, smart switch expressions, good. Good, so let's suppose I work in a highly regulated industry and I want to describe data of type loan, like a financial services company of some sort, okay? Well, these are highly regulated industries. If you make a mistake in the code, there could be legal ramifications, right? Just ask Sam Bankman-Fried, right? I don't think those were mistakes, but still. The point is, you want to make sure you get these right? You don't want somebody coming along and creating an anonymous inter-class implementation that sidesteps all the validation that's required. So I can describe this as a sealed type, right? Well, now I can have I can explicitly enumerate the things that I'm allowing to subclass that interface. So I might say class secured loan implements loan, right? Implements loan. And I might have an unsecured loan that implements loan, and the compiler is not happy with me. It's saying, oh, look, you haven't made this sealed, and you haven't explicitly permitted other classes, therefore, I'm not going to compile. So I can make this sealed by finalizing it, like this, right? Or I can permit other classes. Or, third option, if I want, I can make it a record, which in turn is implicitly sealed, right? It's implicitly final. So either way, that's pretty good. Now, what about these records? You saw me creating a record down here. In Java, we don't have tuples. How many of you know what a tuple is in other languages, right? Tuples are just carriers for data that are typed, right? So the first element might be a string, the second an int, the third a date, whatever, or date time, or instant, something more useful. And in Java, we don't have that per se, but we do have records. Remember, Java is a nominal language. Everything in Java has a name, right? And so these are, in effect, records with names attached to them. Okay, very, very convenient. And the contract is pretty straightforward here. If I have a float interest and I have a Boolean, flag of some sort, and blah blah blah, if I create a string x and int foo and whatever, then the contract of this unsecured loan, the identity of that unsecured loan, is equal to all of the identities of these different components, these things that I'm passing in the constructor, combined. And I know that if I want to recreate the unsecured loan exactly as it is, because it has no derived state, I know that if I want to recreate that state, I just need to recreate these components, right? Very, very powerful contract, because again, there's no I can't do this. Float value equals 1.0, right? There's no class variables for this. No derived state. It's only the state of the object is equal to this. And if you agree with that contract, then the language can do some amazing things for you. It can make sure that you have a constructor and storage for these component fields that I just created. It can make sure that you have getter methods or accessor methods for them. It can make sure that you have toString and equals and hash code values functions for all of them. And it does that all for free just by using this keyword. Very, very convenient, right? This is an optimization for data. So now I've got two different types of loans. I want to explicitly permit two kinds, right? Secured loan, unsecured loan. Okay, so now I've told the compiler I want nothing more than these three. Somebody can't come along, fraudulent loan, implements loan, right? This doesn't work. The compiler will not let me compile this program because I need to explicitly tell loan that I permit this other one. So I can't create an anonymous inner class as well. Okay, so I've got this loan type. Now I want to display a message for it. So display message for loan, right? Loan, here we go. And let's say I want to create a message like this. Message equals, there we go. And I want to return a message to display to the user based on the kind of loan they've got. So if loan, instance of secured loan, then message equals, well, first of all, maybe I have to, good job. Well done. Nice job, right? Good loan you got there, right? Very, very friendly message. Okay. And then imagine you got an unsecured loan. So if loan, loan, instance of unsecured loan, and then I need to actually downcast it, so I'll say USL equals unsecured loan, loan, and here I'm going to say message equals, ouch, that, let me see, that USL.interest rate is going to hurt, right? Very, very user hostile message. Okay, so now I've got these two different things. Can I clean this up? Well, first of all, I can use pattern matching. Down here, I can use pattern matching. You see, I'm matching this pattern. I'm saying I know that this is an unsecured loan in the context of this block. So why can't the compiler downcast it for me and provide that variable? Well, it can. So now, this is the pattern, and this is the extraction of the variable, okay? So within the context of this, I know that this is a USL. I can dereference fields that are unique to USL. Remember, interest doesn't exist in loan or in secured loan, just USL. I can go a step further, though. I can actually, because remember, that's a record. So I can actually extract out the interest as well as a variable. This is pattern matching, or sorry, deconstruction, basically, pattern deconstruction, right? I'm matching the shape of the loan, whoops, I'm matching the shape of the loan and the constituent components, and I'm extracting it out so that within the context of this string, that interest is a float. So I don't need the unsecured loan, I just need the interest, and I can get it there. So that's pretty nice, but still, what happens if I comment this out? Nothing. The compiler has got nothing here, right? Nothing is wrong, I didn't do anything, except now I'm not handling one of the two very important pathways for this algorithm. So what if I go a different way? What if I use a smart switch expression? So I can say, switch loan, okay? Case, and I'm going to do unsecured loan, like that. And so here we go. I'm going to do the same kind of thing we just did, right? So var interest. If it's that, then I can do an expression. And notice that each block, each branch of the switch is an expression. It returns a value, right? So I don't have to assign it and then break. I can just return a value as well, okay? So that's really nice. Look at that. Much cleaner, actually. And in fact, I could probably just get rid of all this intermediate stuff. Right, there we go. And in fact, I could just get rid of that too and get rid of this. Okay, so now I've got pattern matching and I've got the smart switch expression. Switch expressions can be exhaustive. So if I do that, what's happening? Well, the compiler is saying, hey, you didn't cover all possible input values, right? The compiler is helping me make sure that I do the right thing. So this is actually both cleaner, more concise, more elegant, and more type safe, right? It's very rare that you get all that in one feature, or one set of features. So you can see how these things taken together, all, taken individually, all pretty useful. But taken together, they make it a really, really nice experience for people building Spring applications that are typically used to build, among other things, back-end services, okay? Okay, so I guess my point is don't sleep on ye old records because they are part of a whole ecosystem of features called data-oriented programming, okay? Now, we've got a record. We need to persist it, obviously. Customer repository. Thank you. Look at that. That was the first code completion I've gotten in a while. That was like, oh, thank you. So we got the customer repository. What else? Controller. Here we go. Response body, customer, HTTP controller. I'm laughing now, but one day that code completion is just going to do my job, and it's going to feel very sad. Here we go. And then the ultimate insult will be it'll do a better job than I do, which is, don't like that at all. Okay, here we go. So we got this. Got the endpoint customers. Okay, collection now, customer. Good, return this repository find all, et voila. Okay, what is wrong with you? Why are you upset at me? Iterable, haha. Oh, it's a list of CRUD repository. See, it wasn't so useful. It didn't know what I wanted. There you go. Okay, so I've got my simple HTTP endpoint. Let's go ahead and start it. Did we already start it yet? No, we haven't. So we'll start it for the very first time. And remember, it's going to start up that Docker image. It's going to start up that Docker image for me. Here we go. You can see it taking achingly long amounts of time, because it actually started container service. It's talking to the Docker daemon on my local machine. It's running the Docker image for me. It's running Docker Compose, basically. Okay, so the application's up and running. And I'm using DevTools, though. So now I don't have to do anything else. I can say, hi, map, string, hi, return map.of. Okay, message, hi, right? Okay, so now I don't have to restart that, just Command Shift F9, right? If you go here, you can see recompile on my machine. Build, recompile, Command Shift F9. and that restarts the program. So if you can see here, it restarted now, and it restarted everything except for the Docker image in 0.4 seconds. So now I go here. Oh yeah, hi. So localhost, hi, okay. Making progress. We got ourselves a data-centric application. We've got data in the database. We're moving quick. Git clone run. We've got our data access. We've got an HTTP controller. We've got a repository. We've got that nice, clean Java 1 syntax. What else? Well, it's 2024. Obviously, like I say, everything these days is going to be AI. You need AI. And we have this incredible project called Spring AI. Spring AI supports the entire RAG pipeline. RAG is Retrieval Augmented Generation. Don't get scared, by the way. There's no Python involved here. Okay? When people talk about AI these days, remember, there's two sides to every discussion. Don't get fooled into thinking you need to worry about the first side. You care about the second. And what I mean by that is, you don't need to know C to use a SQL database, right? Just because most SQL databases are written in C doesn't mean you need to know that. Likewise, just because most of the LLMs are built using code that uses Python, you don't need to know Python or any of that key chain, that tool chain, to integrate it into your programs. You just need integration, just like JDBC, but for AI. And there are 4 key dimensions here that I would encourage you to think about, right? One is, how do I talk to my LLM? That's called a chat client in Spring AI. There's a vector store if you want to talk to your vector database. If you want to decide on how you embed the database, how you turn your data that you store into a vector database into something that can be stored, text, images, whatever, you need to create an embedding, and that means you need an embedding client. And then finally, if you want to generate images for the LLMs that can do that, you need the image client, right? So these are the 3 core abstractions in Spring AI. And you use them together. Typically, you just use a chat client. Maybe you want to optionally store things for easy searching in a vector store. Behind the scenes, the vector store might use an embedding client, and you might alternatively also use an image client. That's it. That's the entire AI hype right now. The entire RAG pipeline consists of doing these 4 things, and usually not even all that. Okay? So I'm not going to show you all of this today because we don't have enough time, but let's do something. Let's create a simple HTTP controller, AI controller, okay, and we'll inject ye old chat client, singularity. Okay, here we go. And in order for this to work, you need to connect to your AI LLM. Well, of course, I've got on my build the Spring Boot starter, the Spring AI Spring Boot starter for OpenAI. But there are many other AI LLMs that you can use, including many that you can run on your local machine. In fact, there's one called Ollama, which in turn acts as an API, an interface, for a number of different models. So it's like Docker, but for models. So you can run Ollama on your machine and then run free open source models on your machine as well, all completely offline. No need for an API token, no need to pay anybody, etc. Okay? And if you want to switch to Ollama, you just switch this, right? Switch to Spring AI Ollama versus OpenAI. Okay? OpenAI being, of course, the one thing behind ChatGPT. Okay, so we've got this. I've got the application here. Let's create a simple endpoint here, huh? Story, map, string, story time, okay? And we're going to return a little simple HTTP endpoint message, and we'll put a string in there, and we have to create the query, the prompt, as we say. Look at that, another great use of multi-line strings, not just for JDBC. Response equals this.singularity.call, passing in the prompt, okay? Now, what is going to be our prompt? Well, we will say, dear Singularity, please write a story about the amazing Java and Spring Boot developers in the city of London. London. Okay, and please do so in the style of famed children's author, Dr. Seuss, another one of my favorite doctors. Cordially, Josh. Okay? Very important to be polite. The machines will remember this. I've seen Terminator. It is a documentary. You've got to remember the politeness. Very important. Okay, so we're going to ask for a response. That'll give us a string. We put that here. Okay, send it back. Command-Shift F9. You can see it's reloaded. 0.37 seconds. Thank you. Localhost, what did I call that endpoint? Story, thank you. Here we go. And I will drink some water. All right, so I had a bit of time there. What did we get back? In the city of London, in the land of tech, live Java and Spring Boot developers. Oh, what a spec. They coded and programmed with such grace, creating websites and apps all over the place. Their skills were unmatched, their code so clean. They were the best developers that have ever been seen. With Java in hand and Spring Boot in tow, they worked tirelessly, always in the know. They built apps for their big businesses, big and small, helping them grow and stand tall. Their websites were sleek, their code so tight. They were truly a developer's delight. You get the idea. AI can do amazing things. It really is an amazing time. And again, this is just me asking a question and getting a response. Where the real value comes in is if you can then send in the body of the request information about the data that you want to analyze, right? And then send a user's query. So the user can say, hey, I'm looking at one of these products in your catalog. Please recommend other things from the catalog that look and feel like this. And you can give it information about things. You can find those similar products by going to your vector store, finding similar things using cosine similarity. Then take that, put it in the body of the request, and say, okay, I found the top 10. Given the user's request, analyze all the descriptions of these other products and give me the one that most efficiently matches. That's RAG right there, right? And so you can do amazing things with this. But first of all, did I mention that you have to specify a credential, OpenAI API key? I've already done that. I did that off screen as an environment variable. I'm not sure if I mentioned that, very important. So if you're wondering why that worked, because I didn't specify a credential, I did. It's an environment variable in my operating system. Forgive me for not leaking my API credential. Okay, so we have this API endpoint, we have got that, but what happened when I made that request? I had time enough to drink some water and some coffee and so on. I just sat there for ages, waiting and waiting and waiting. Nothing came back, right? And this is okay. Again, I am really grateful for the response. I'm really grateful for the work that was done. But that said, it took a long time, didn't it? And during that time, we have to think about the implications of this on our system. Right now, we're using a servlet container, and there's a one thread per request sort of approach here, right? I make a request. The dispatcher servlet is a servlet in the servlet container, in this case, Tomcat. The container wakes up the servlet. The servlet, in turn, finds the controller. It finds the method, invokes the method, passing in the request body, and allows me to make the process, process the response. I do that by making a network request in the same thread to the OpenAI HTTP API. All of that happened, but it took several seconds. Most of that wasn't interesting. There was several seconds of me waiting for the thing downstream, the HTTP service that I was using, to make the response, right? There's a couple reasons why that might have been so slow. It's worth noting that if you had used Ollama, this probably would have been a lot faster, right? Ollama is local. There's not a lot of demand on the system, etc. So you can get actually faster responses, but this does demonstrate the point, which is you're wasting a lot of time waiting for a response, aren't you? And this has implications for your system because your system can't scale, right? Your system's not going to be able to continue handling more work if it runs out of threads. Threads are expensive. They are a precious resource. Up until now, that is to say, right? Up until now, because until now, we've had one kind of thread, operating system thread, which maps to Java thread. But now we've got a new thing called a virtual thread in Java 21. And this is, like I say, I think the single most impressive thing that's been added to the JVM. And the thing that makes me so happy is it did it without breaking 28 plus years of legacy code, of existing, well-designed, well-crafted code. They made it so that these things can opt in seamlessly. So let's take a look at an example here. Okay, I'm going to steal an example from my friend and fellow Java champion, José Pomar. Okay, merci, José Pomar. Okay, he's a professor of computer science at Oracle, in France, and also he's a Java developer advocate at Oracle. I got them conflated. And he has this great example, and I'm just going to steal it, just shamelessly, unapologetically. Let's suppose I want to create 1,000 threads, okay? Here we go. I'm going to create 1,000 threads, and for var I is 0, I is less than 1,000. Come on, Josh, you can do this. Good, look at that. Okay, and I'm going to say var t, this is a single thread, thread.of platform. This is the existing kind of thread. New runnable, blah, okay? And what am I going to do in those threads? Well, we'll come back to that. But now that I've done that, I'm going to go to each thread, and I'm going to start it, and then I'm going to join. That is to say, I'm going to wait for each thread to finish. Okay? So two different things. Go through each one, kick them off, and then wait for each of them to finish so that we don't get to this line here. Okay? Finished all threads. Okay? And then finally, I'm going to print out something. What am I going to print out? Well, I'm going to print out the name of the threads that I see on just one of the threads. And I'm going to use a set. If you know your basic computer science data structure theory, you know that sets dedupe the elements. If you put, the number 1 in a set 5 different times, and then you iterate over that set, you'll only see it one time. Okay? So I'm going to print out the name of the current thread as I recorded it. So I'm running 1,000 threads, and each one of them has their own thread name. I'm going to add that to the set. Okay? It's a silly thing to do, but I'm going to do it. Okay? Add thread.currentThread.toString. Okay? And then I'm going to sleep. Now, this is important here, is I am going to do a thing that wastes time on the thread. We call this a blocking operation. Input stream.read, such as I'm doing when I call the OpenAI API, that's a blocking operation. I cannot go from input stream.read to the next line in the program execution until input stream.read returns control and gives me back control of the flow of the execution. Can I? We say that's a blocking operation. If it takes 5 minutes, I wait there for 5 minutes. Hopefully, you're doing something like a circuit breaker, a Spring Cloud circuit breaker. Hopefully, you've got some designs in place to make sure that if something goes wrong, you don't just have a runaway thing that never ever returns and never returns the control of the thread back to you. But you could, right? This is a problem. So that's a blocking thing. Output stream.write, whether you do it with a file or a network socket, is also a blocking operation. And thread.sleep is a blocking operation. So I'm taking note of the current thread name, and then I'm sleeping for, let's do this, 100 milliseconds. And then I'm going to copy and paste all this, and I'm going to do it 3 more times. So 1, 2, 3. Okay? There we go. So I'm starting the program up. It's going to sleep for a total of 500 milliseconds, and then I'm going to run all the threads. Okay? Unreachable code 4 T. Oh, did I not add the thread? Yeah, okay. T.add, no, sorry, threads.add T, okay? Threads, here's the thread here, names, oh, down here, right, okay? So I'm adding the thread that I've just created. So I've got 1,000 threads, but I'm creating scarcity of resources. I'm launching 1,000 threads. The system has to schedule them all, and it's going to run out of actual operating system threads on which to do it. So we're going to take note of the time of the current thread name. We're going to sleep, take note, sleep, take note, sleep, take note, etc. So let's run this. Let's see what we get. Oops, I restarted it by accident. I should have just done Command-Shift F9. Oops, we should also check and make sure we're on the first one. I forgot to do that. var I equals, sorry, are we on the first one? We say var first I equals 0. So if we're on the first one, that's the important part here. If we're on the first one, then and only then do we want to take note of the name. We don't want to see all 1,000 threads, just the first one, okay? Now, restart. Oh, I restarted it again. I should have used DevTools. Okay, so, well, actually, no. There you go. Finished all the threads. You can see we have a collection of one thread. So it's called thread number 93. Here's the thread pool, etc. Okay, so that makes kind of sense, right? Like if you're in San Francisco, where I live, and you're on Market Street, and you're walking on Market Street, and you look up, and there's a sign that says you're on Market Street, and then you walk 200 meters, and you look up, and guess what? The sign still says Market Street. Since you haven't left Market Street, you walked in a straight line down the street, it's not entirely surprising to you that when you look up and look at the sign to see where you are, it still says Market Street. That's what you'd expect in a world where the physics that we have all well understood hold. But that's not true anymore in the Java world. So now, instead of using a platform thread, I'll say a virtual thread, okay? Command-Shift F9. And here, look at that. Market Street is not Market Street. Here, the operating system has a number of threads, but we have virtual threads. The runtime detected we're sleeping, so we're therefore wasting time. It unmounted the carrier thread, the operating system thread, moved the code off into RAM, set an egg timer, waited for the input stream or the output stream or the thread.sleep or whatever to finish, and once it finished, it moved it back and put it on another operating system thread. But we didn't sit there on the thread in the meantime, wasting time. That thread was available for something else in the system to reuse. This gives you really good scalability. I did a demo earlier this week with the good Dr. Subramaniam where we looked at virtual threads. And I forced a 3-second long blocking operation. And in that example, the total time to finish all tasks was 3/4, 75% shorter when I use virtual threads. But most importantly, the longest time it took for any one thread to do its work was about 3 seconds compared to without virtual threads, almost 9 seconds in some cases. So the immediacy of the response and the overall time to completion was just much better. Much, much better by using these virtual threads. So this is all very low level. Hopefully you're not writing code in terms of threads. If you're using Spring Boot, you can just let us do that. So we added this property in Spring Boot 3.2. Spring.threads.virtual.enabled. If I were you, I would take this property, tell your management you're going to dramatically improve the scalability of the system. Tell them you need 2 weeks and to not be disturbed. And then just disappear. Go on the beach or something. Upgrade to Java 21, set this property, and come back 2 weeks later. And then insist that the cloud infrastructure spend that you've recouped by saving scalability resources be put in your bank account as sort of an incentive, a reward, if you will. Okay? This is an amazing deal. And this is the Java team doing what they always do, which is introducing amazing new things sort of without disturbing 28 years of code. An amazing, amazing feature. Single most important thing that I can think of that they've done in a long time. And by the way, this is compared to what every other language has, which is async await, which is a sort of, it permeates your code. You have to add async await to all the places in your code where you want to tell the runtime you're going to do a blocking thing. In Java, the runtime just figures that out. You're blocking, therefore, we're going to move you off the thread. You don't have to tell it anymore. This is one of the very few cases where we can say with confidence that Java has the more concise syntax. It's an amazing time to be a Java developer. So now we've got an application, we've got scalability, we've got the freaking singularity. We're doing really good, really good. Time to go to production. Obviously, there's some concerns here. How do I turn this into a Docker image? Obviously, you can use, let's see, skip tests, p native. Sorry, not that. We want to do skip tests, spring boot :build -image. That'll build a Docker image for you, right? And that, in turn, behind the scenes, uses build packs. This is a cloud-native computing foundation specification, and it provides a nice way to easily take an application artifact, be it a .jar, Ruby on Rails application, .NET application, Python application, whatever, and containerize it for you. Remember, friends don't let friends write Docker files. Don't do it. Be the change you want to see in the world. Do the right thing. Use build packs. And if you're using Spring Boot, you can just run this plugin, and we'll do it for you. It's nice. So that's one thing. But I also want this application to scale. I want it to be more relevant, more scalable, more safe, more available in production. And it's here, my friends, that I want to stress that I think that Java is already very, very, very nice, right? And I think there's a couple of things that point to that. First, here's the blog from the New Stack from 2018, before the COVID pandemic, or BC. And this blog asks the question, which language uses the least electricity? So let me see if I can copy the image address. Here we go. There we go. Total normalized global results for energy, time, and memory. And you can see that C is 1.0, the baseline, okay? Not so confusing. Rust, zero-cost abstractions, very well done, good job. C++, tui, disgusting. Moving on. You've got Ada, but nobody cares, and then you've got Java. And Java is top 5 most energy efficient. Top 5, with the likes of these languages. All interesting languages except for C++, right? Amazing. Top 5. That's a really good result. That was 5-6 years ago. 2018, right? So now you go down the list. What else you got? You've got C#, okay. You've got Go, away. You've got these disgusting languages. The less said about which better. By the way, how is JavaScript 4 and TypeScript 21? I don't understand. I thought one compiled into the other. Yeah, but it's not at runtime. It's a type-safe blanket. It doesn't exist. It's like it's not a real language, right? It's byte. The JavaScript is the bytecode basically. So I don't know. Okay. Anyway, moving on. Then we've got Hack and PHP. The less said about which, the better. Moving on. We've got Erlang. Okay, and then we've got JRuby and Ruby. Friends, JRuby is Ruby written in Java, and Ruby is Ruby written in C. And yet, somehow, JRuby, by virtue of the fact that it's running on the JVM, is almost a third more energy efficient than the equivalent C code base. The JVM is amazing. It's an amazing place. And then we've got Python. And this makes me really sad because I love Python. I've been using Python since the 90s. Bill Clinton was the president in my country when I started to use Python. But this is not good. This is especially worrisome in the world of AI and so on. This is worse than Bitcoin. Think about this, right? So let's say 76, just round up. And then for Java, just scroll way up there. Java, let's just say 2.0, okay? Rounding up. So I'm not very good at math, but you know who is good at math? Freaking Python. So 76 divided by 2, that's 38. What that means is that if you write a Java program, and that program uses energy, which in turn results in the capture of carbon in the atmosphere, and that in turn results in the heat of the planet, of the Earth, increasing by just so much as to kill one tree, then the equivalent program in Python would kill 38 trees. That's a forest. It's too much. It's too much. So we need to have a conversation about that. I don't know when and where, but we should. Anyway, moving on. What I'm trying to say is Java is energy efficient. It's also really, really fast. How many of you have seen the Gunnar Morling 1 billion row challenge, right? This is an amazing effort from January and December of last year, January of this year and December last year, where our friend and fellow Java champion Gunnar Morling asked people to calculate some statistics about 1 billion rows of text data representing weather station data, okay? How fast can you write a Java program with no frameworks, nothing else, that starts up, processes, does the statistics, and then prints out the results and quits? Turns out the fastest implementations can do it in about 1.5 seconds. From allocating the process to cleaning it up and then exiting, all of it, 1.5 seconds. So it's also very, very fast. That's my next point. It's using GraalVM. Most of the top ones are using GraalVM, but even there, a lot of them aren't. But that is true. I like Java. Java's amazing, but I still think we can do better. So the question then is, how do we squeeze more out of our existing, already amazing runtime? And that is a good point. We are going to use GraalVM. GraalVM is an OpenJDK distribution. It supports OpenJDK plus some extra utilities. And Spring Boot supports that as well. So let's go ahead and create a GraalVM native image. And what I'm going to do is I'm going to do Maven skip tests, because I didn't write any tests. Native compile. We'll let that do its thing. And of course, this is my only problem with GraalVM, is it does take a little while. We have to wait for it to do its thing. It's going to do an analysis of all the code. It's going to find all the code that my code is using, all the code that that's using, all the code that that's using, and so on down the line. And it's going to put all that in one bucket. And then everything that it's not able to explicitly say for sure is being used by something in the code, it'll throw it away. That analysis is expensive. It's looking at the JRE, the class path, and your code base. So it takes a little while. I get it. Nonetheless, it is a little bit problematic for me. I get bored very easily. I have a minor ADHD, I guess. So I just sit there. I just like stare at the wall, stare at the window, look out the window in my building in San Francisco, whatever, right? I just get very bored. And it gets to the point where like, I've learned now not to doom scroll, not to start doing that, because that's going to really distract me. So I start to hum. I start to hear music in my head. Do you ever do that where you're just like, okay, I'll just play some music, just hear something in my head. And I start to hum, and I get very distracted this way. And it gets to the point where I eventually hear elevator music. Do you know what elevator music is? It's the music that people play, that interminable music that people play in the lift, you would call it. Lift music. I'm not sure if that's the right thing. And it got to the point where I thought, wouldn't it be great if everybody could hear this music? So I went to the GraalVM team, and I asked. I went to Oracle. And I said, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head while I do these sometimes long-running compilations, and I'd like everybody else to hear it too. Thanks in advance. I appreciate your work, and I do. I got some great responses. Somebody suggested using a beep sound, like a microwave. That's a great idea, right? Somebody else said, this is Dr. Fabio Niephaus. He's on the GraalVM team. And he said, thanks for your feature request, Josh. The problem with playing music during the compilation is that it's just fixing the symptoms. And we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Go on. I have prototyped a -- Josh long mode. So this is what this would look like. You run the native image compiler, native image -- Josh long mode, and it would say music brought to you by Josh Long. This is a picture. But don't let that stop you from understanding that there's music playing at this point. You can hear it, and you're wondering who did this to you. Why is there music playing? you're looking around and it says, oh, music brought to you by Josh Long. That's me. And then you're like, okay, well, I'm still kind of bored. I want something to look at. And so then this appears, right? And that would be, I think that's going to be great, right? Right there. I'm sure that'll get merged at any point soon. Where were we? Right. Okay. This. Service. Oh, port is already in use. Let's go over here. Okay. Stop the existing one. The Java one. There we go. 0.1 seconds. Up and running. Very good. The thing I love about this the most, of course, is the process identifier, which is over here. I can measure the RAM. So PS minus O, RSS. That's measured in kilobytes. That's the RAM of the program. So you divide by 1,000. So it's 118 megabytes. Try opening up CNN.com in Google Chrome. I dare you to get a tab that takes less than 600 megabytes. I dare you. Meanwhile, I have a super scalable, AI-connected application that starts up in tens of milliseconds and takes up takes up 100 megs of RAM, and I can do it in a seventh of CNN.com and Google Chrome. It's an amazing, amazing time to be a Java and Spring developer, and I hope I've so persuaded you. First of all, thank you for your time. Second of all, who had fun? All right, who learned something new? Very good. I appreciate you all. Have a great DevOps. Thank you. See you next year. Thank you.